Welcome back to another Alephium video. This is going to be part 3 in our multi-part series for building on Alephium. Um, so let's get started, right? In the previous video, we were looking at just kind of how to actually start building like a contract. And now we're going to start looking at how we can expand upon what we started to build and actually make functions within a contract that will actually be able to execute and either, do something weird with the token or make a new token or send out an existing token. And that's kind of what we're going to be doing. The approach that I'm taking to this is pretty malleable. So our contract, while not in theory something that somebody may not, somebody wouldn't build this, right? But I think it shows a lot of the ways that you could go about building something on Alephium, and in that sense, I think it's just the best way to kind of explain what's going on here, right? So we're in our contract thing. This is where we left off from last time. Just making sure this is saved. And one thing I do want to clear up from last video is that when I say token create here, when you have this little import script up here, you're basically defining here that this is a token that is already being created. So this contract itself is a token, right? It's this is what it is. And this down here can, it makes sense to have it if you're wanting to build like a contract off like another contract. So in this case, it would do that. But in this case, the best way to think about it is like a box. And in this case, you'd have like a withdraw token, and like a public function to like deposit a token in here. And for this, we could probably use Alf. I think that's probably the best way to implement it. And obviously you need these two things overhead. But this typical structure right here is how you would achieve, what you're trying to achieve, right? So you'd have a withdraw, which would allow you to take token. And this is the token that's made in the contract. This is the contract token, which is the token that is defined by this name, symbol, and supply, right? And then for this deposit function, it's you're depositing a token. So you're depositing a token, and it's going into the contract. So, and this the contract takes Alf. Takes Alf, right? So this is what it can look like, and then you obviously here you could have a public function for dev withdraw. So this is kind of the important thing, I think, with any token if someone was building it, right? If you saw this here and you saw like, I don't know, the contract, we'll do an example of it, but they were gonna like take all the tokens. That would probably be a pretty good indication of a rug pull, unless otherwise specified by them with good reasoning. Otherwise, usually it's like a dev fee or something associated with like the token moving. And so in that sense, it's like a gas fee almost. But we don't want to do that. So yeah. We'll do it just to show off how it would kind of look, but this is just like a dev withdraw. I guess if you guys were going to do a token presale, this would kind of be the way to do it, maybe. Take token, take Alpha is what it's taking. Right? No, this will return you alpha. Contract takes token, returns alpha. This withdraw is takes alpha, returns token. So the opposite. Could just name this better name was deposit. It's fine. Just leave it as is. But this is what these functions do here. Moving over here to events. Events are a key part of building contracts. And that's kind of the main part of today's video, right? Is building out these events. So one of the events that we can have is like for this one, it's a withdraw. So we'll just type in withdraw, and then we'll specify, we don't have the contract built yet. So basically these are all going to be things that are going to be part of the actual contract. And we have a dev withdraw. Take a notion of the syntax style that I'm using here. If you don't use this syntax style, you could run into just issues using the documentation. So that is something to, look at and consider, right? Hold on. I'm making sure that I have this exactly right for you guys. Yeah, this should work, I think. I think it's better just to build out the actual token thing first, right? It's just easier, I think, in my opinion. So we'll go and do that. We'll start working on the contracts first, and then we will come back around to using these event handlers, right? All right, so before you use them, do this number here. You want to specify them as events, and then we'll fill in the rest once we finish off the contracts a little bit. As far as error codes go, this is just a simple enum. Not very complicated. It's just enum, and then I name it error codes, but you can name it whatever you want, which is equal to this, and then invalid. We'll just say invalid. Invalid equals 1. And we'll say valid equals 0. And that's all there is to it. It's really that simple. It's not very hard. Alright, so we finished events, we finished error codes. We're going to use all of these now in the contracts that we have down here. First thing we're going to do is make our withdraw. So we're going to think about this and what we want to happen. Are we using contracts in the asset? This is basically asking if we're using, let's just do an example, right? So for withdrawal, we're going to say we're taking alpha and returning token. So we're going to set a rate. Let's trying to think about how we want to do this here. Yeah, let token rate equals 0. No, we'll do Just do like a 1-to-1 ratio. You turn in 1 elf, you'll get 1 token back and forth, right? That makes more sense. So what we're going to do is we're going to assert that there's going to be no amount. It's just a function. So there's going to be no params in here. No params in here, I mean, because we're not taking a preset defined amount. It's just going to be a constant amount, right? But we could, and that's an option that we have. So if you wanted to, it would look something like this, and you would specify it as a U256. So that's what it would look like if you wanted to. And we'll just do assert amount equals 1, making sure that it equals 1. If not, error codes dot invalid, and that basically allows us to give ourselves better debugging, right? So just using that error code alone will tell us, hey, this is they entered an invalid amount, right? And we can do that over here, actually. We can say error code there we go, invalid amount equals 2. And we can say invalid. I like to leave them all lowercase personally, but that's just me. You guys can do it however you want. Boom. And then for our next one, we can decide how it is we want to go about it. I think we should work on transferring the token. So we have to transfer 1 token to them, 1 token to us kind of deal. So we're going to transfer token from self. Actually, I could just do transfer token. Let caller equal caller address. If you don't know what that does, this basically will get the caller's address. So caller address. And looking at the token transfer, we can see that if we click on it, usually it'll show us actually I think it's transfer token. Yep, it'll show us kind of what the params that we need. So it's a from address, a to address, the token ID, and then the amount. So for us, it's going to be from the caller to this address. So we have to actually get the contract address now, which is a function that we can find in the Alephium docs. But I'll just pull it up here for you guys. The built-in functions. Here it is. And we want self address. So this is what the function looks like. Bam, self address. This function right here returns the address of the contract, which means this is where the tokens are going to be sent. Token ID of the token. I think we can just use self ID maybe. Self token ID is the function that we can use. This will get the token ID of the contract. And finally, the amount, which is already specified by the amount tag right there. So this right here is enough right here. So this will transfer token to user. And then we can go back and we can transfer token the same way, except the other way around. So we can go from, now that we have that and the token, we can go instead from, actually the from address, this is from, so this is actually going to be our alph transfer here. So we are accepting payment first in the contract, and we are going to be asking for alph, which is in this case a keyword. And then we are going to be flipping the script. And this is where we will deliver our token that we made ourselves in exchange for, you know, the alph that we had just received. So, and then bam, amount. And then this obviously will never exceed that hard-coded one limit via this one right here. So we'll just say that's the token transfer. There we go. Yeah, everything looks good here. There we go. And then we can do kind of something similar here. But first we're going to test to make sure our contract runs and compiles properly. You can't do long commands in Ralph, can you? Let's see if you can or not. That would be a good question. Inheritance, annotations. Doesn't look like we might be able to. So for now, we're just going to close all this out. And we're going to do an npm run compile and see if our scripts compile. So probably got an error in the contracts here. We expected something after supply. That's because you can't have that. That fixes that problem. And the rest, let's see here, another error in the contract. Error codes expected. I don't know if there's an equal there. That's probably the problem. All right. And another little error here. Does not update fields. Please remove true. So we're not updating any fields that would be here. So if we're not updating fields there, we set that to false. We are, however, not checking the external caller. So we're going to run compile again. And now it's probably saying that we're not using pre-approved assets. No, we just didn't save it before we compile. There we go. And found unused constants. For this case, if you don't use an error code, it doesn't want it in the contract. Rightfully so, we're trying to minimize the amount of code in these contracts. garbage is not really something that is appreciated. However, it is there. So this compiled. This contract is compiled and it was accepted. So now we can do kind of a similar thing on the other side, and yeah. So anyways, so now we can go back and do this. So we're not updating fields here. So that's false. We're not publicly functioning or depositing, so that's fine. Here, here, here. And we can copy paste a lot of this code because it is the same in its general structure. So I'm going to do that. And then I can show you how these events work after I have all these in. So after these events work, all I'm going to do is I'm going to say, hey, they've done a withdraw. The withdraw parameter that I am taking is amount. However, I can put more in there. So don't think of it just as this parameter, but think of it as anything that you'd want to know. So in this case, for the withdraw, I want to know the user who withdrew. So this is an address. I want to know the amount that they withdrew. So this is a U256. And that's all I really want to know. So I take this withdraw, I go down here, and I say, why am I blanking on what I tell the contract to do? I do an emit, withdraw, and then I fill in with what I had just received. Rightfully so, this comes out to be what the information that I wanted, basically. So I have my caller, and I have my amount that I wanted all in there. And that's all. And I can do that with all of these. Obviously this one's a bit different because it's not the same, but I can omit the amount, and I just change it from withdraw to deposit. Same thing goes here, and I can do, instead of withdraw, I can do dev withdraw. That's not something I have. Oh, it is something I have here. Withdraw. And I can say the same thing, caller amount, same deal. So then if I compile these, it should do what it's already done, except for the fact that we're not updating fields here, so that should be false. Oh, and we did not specify this within our other events, which is kind of important. However, the contract itself did compile anyways. No, it did not. Should now, though. Whoop. And still a problem. Variable deposit.amount does not exist. Oh, because it's not in here. And by amount, this just basically means let amount equal, this is where like you'd hold a balance of like the alpha that you have. So we could say like alpha balance. But typically with this, you wouldn't do all this on this contract. Instead, you would have a token, and then you would make a separate contract without even this right here at the top. And you would just grab the token ID and you would use it throughout here. This is kind of an interesting use case because we're trying to merge the two, which isn't a problem. It's just kind of a weird way to do it. So for now, we'll just say that he can take one. So he's gonna have it's gonna be a very, very slow rug pull if he wants to rug pull. It's going to be a noticeable rug pull as well, because he's just going to be spamming the contract function, and it'll take all the time it takes for Alf to do the transaction, however many times the token has. So, okay. So, and then usually you'd have a balance in here to specify like the balance of the token. So because that's kind of important for this, I'm going to actually put that. And balance is just going to equal token supply at first. So, yep, that's all we need there. And then to do that before we even have the token, we're going to take balance equals balance -1. Actually, this is +1. Nope, it's -1 because the token. And then balance +1. There we go. Because we are getting our token back. So that should work. All right. Cool. Okay. So save that. And unfortunately I have to flip these scripts a little bit, so this isn't that hard. It's basically just flipping these. So instead of one side taking it, it's now the other side, and vice versa. And bam, that does the trick. So now we can compile this code, and it should be good for the most part. There's a little bit of an error here. Assigned to immutable. Oh, this is a good time to talk about immutable variables. If you want it to be immutable, it has to have a mutability thing on the front of the balance. So, otherwise it would not be mutable, and you would not be able to use it. This is good building right here. Good building. And another error. Let's see how we can handle this. Please use update fields. Oh, because we are updating the fields now. Didn't even realize that I was doing that again, but yes, we are updating the fields. So now I can show you that it does actually know. The compiler knows whether or not you're updating the fields. And we'll run another compile. And the contracts have indeed compiled. So that is that's it. It's enough for this video, I think. In the next video, we'll write the scripts to use these contracts, and we will make the web page for actually calling these contracts from a website standpoint. So hopefully you like this video, and I'll see you guys in the next one. Peace.